Today we start one important topics related to algebra. Okay, we also discuss one special topics. This topics is familiar to all. We know about polynomials. Okay, today we discuss this polynomial. Okay, so we start from this beginning. We write now the definition of a polynomial. Okay, we write it here. Definition of a polynomial. Okay, a polynomial fx divides. Okay, a polynomial gx divides a polynomial gx. Okay, such that what if there exists a polynomial qx, there exists a polynomial qx. Okay, such that gx equal to fx qx. Okay, fx qx, and obviously this one is the means fx divides the polynomial x. Okay, I write it in this way. This was happened, and obviously we know about that polynomial means, that means some function. Okay, some function, that means some variable is present, and obviously this variable is, that means upper to lower order is here, and obviously some coefficient present in front of this order, this upper to lower order. Okay, then this one is denoted by some function, and then we call it polynomial. So now we're going to further discussion of that. That means today we also going to discuss one important topics. This topic is familiar to all, but we also discuss today the division algorithm. Okay, the division algorithm for polynomials. Okay, we know about that division algorithm for numbers. Similar thing is here. Division algorithm for numbers were also taught in a lower class. Now we also discuss division algorithm for polynomial. Okay, so this basic, common, simple topics were taught today. Oh, oh, otherwise we'll learn today. Okay, I understand about that topics. I think now we're going to write this statement related to division algorithm of polynomial. Okay, let fx be a polynomial. Let fx be a polynomial. Okay, of degree n. Of degree n. Okay, and let gx and let gx be a polynomial. Okay, gx be a polynomial of degree m, of degree m greater than equal to 0. Okay, then there exists then there exists okay, then there exist unique polynomials. Q unique polynomials. Okay, qx and rx, qx and rx, such that what fx equal to, yeah, qx gx plus rx, where what happens at the degree of rx, the mark this one is 1. Okay, and where the degree of rx is less than m, or the degree of rx is less than m. Okay, understood, I think. Now we're going to prove of this division algorithm of polynomial. Okay, this important portion, obviously basic portion used in algebra. Okay, so today we discuss this portion. So we reach our portion and going to further discussion of that. Okay, we're going to prove of that portion. Then this basic division algorithm of polynomial we have to prove out. Then we write it here so easily. We also discuss this too. Okay, we begin by establishing the existence of qx and rx that satisfies one. Okay, we begin by establishing, okay, establishing qx and rx, establishing of qx and rx satisfying one. Okay, then we write it here, case 1. Case 1, if n less than m, take qx equal to equal to 0 and Rx equal to fx to satisfy 1. Case 2. Okay, when 0 less than equal to m less than n or less than equal to n. Okay, then we apply mathematical induction on n. We apply one important, that means proving procedure, mathematical induction, okay, on n. Now we write it now. First, suppose that what n equal to 0, then m equal to 0, then and it follows that, and it follows that it follows that fx and gx are non-zero constant. Fx and gx are non-zero constants. Okay, hence we may take hence we may take okay qx equal to fx by gx and rx equal to 0 to satisfy r. Satisfy what? Okay, so simply we also discuss this one. Okay, if n equal to 0, then m equal to 0, and it follows that if x and gx are non-zero constant, hence we may take qx equal to fx by gx and rx equal to 0. Okay, now we also going to be discussion of that. Now suppose that okay, now suppose that the result is valid. The result is valid for all polynomials. Valid for all polynomials. Okay, with degree less than n. With degree less than n. For some fixed n greater than 0. For some fixed n greater than 0, and assume that what happened if x has degree n, if x has degree n, so what happened, then we write this is 1. Then suppose that if x equal to what, fx equal to a n x to the power n a n minus 1 x to the power n minus 1 dot 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 a1 x plus a0. Okay, and gx equal to, okay, and gx equal to bmx to the power n bm minus 1 x to the power m minus 1 plus dot 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 p1 x plus p0. Okay, and let we erase our portion and going to further discussion that. Okay, and let hx be the polynomial defined by hx be the polynomial defined by, okay, hx equal to here fx difference a n whole inverse x to the power n minus n gx. Okay, then we mark as, then hx is a polynomial of degree less than a. Okay, then hx is a polynomial of degree less than n. Okay, and now we are also discussing of that, and therefore what we may apply the induction hypothesis, we may apply the induction hypothesis. Okay, or case 1, or case 1. Okay, whenever is relevant, means to obtain polynomial. Okay, to obtain polynomial q1 and x and rx, q1 x and rx. Okay, such that what, such that rx has degree less than m, rx has degree less than m, and hx equal to q1x gx plus rx. Okay, so we write markers 3. Okay, then erase lower portion and going to further discussion of that. That means this one we get. Okay, so what happen is here, that means we see about that hx equal to q1 gx plus rx. Okay, then continuing 2 and 3, continuing 2 and 3. Okay, and solving for fx, solving for fx. Okay, we get fx equal to what? Fx equal to qx gx, qx gx plus rx with qx equal to an vm whole inverse x n minus m plus q1 x. Okay, then which established what? Establish a and b. Okay, for any n greater than 0, for any n greater than equal to 0. Okay, by mathematical induction. Okay, by mathematical induction. Then we're going to further discussion of that. That means this establish the existence of qx. This establish the existence of qx and rx. Okay, now we're going to further discussion of uniqueness of qx and rx. Okay, so here we also discuss this one, that implies that means existence of qx and rx we also discuss here. And now we are going to discussion of, okay, discussion of uniqueness. So it is that portion, and going to discussion of uniqueness. Yeah, so we now, so the uniqueness, okay, of qx and rx, of qx and rx. Okay, then what happened? Then obviously suppose that q1x q2x and r1x and r2x, okay, exist and exist and such that r1x and r2x each has degree less than m, r1x and r2x each has degree less than m, okay, and if x equal to q1x r1x, or here q1x qx plus r1x equal to q2x qx plus r2x, okay, then what happened, then we write it here, q1x difference q2x qx equal to r2x difference r1x, okay, we marked as 4. Then what happened, then obviously the right side of 4, the right side of 4, okay, is a polynomial of degree, is a polynomial of degree less than m, less than m, since qx and since qx has degree m, since qx has degree m, it must follows that, it must follows that q1x difference q2x, okay, difference q2x is the zero polynomial, is the zero polynomial, otherwise these two sides are not equal, okay, so this was this happened, then this implies that q1x equal to q2x, okay, and obviously then r1x equal to r2x, so uniqueness is done, okay, not a problem at all, we done uniqueness also, okay, so what happened is here, that means we prove the important division algorithm for polynomials, okay, we also known this one, this familiar and simple proof of division algorithm, okay, so we also known about that today. Now we also going to further discussion of that, okay, that means we give some example related that, so we erase that portion and write about some example, okay, I think all will understand this one is too easily, step by step we prove this portion, okay, then we going to discussion of another, that means topics, okay, So today we all about that qx and rx are this qx with the quotient, okay, and rx with the remainder, okay. Remainder for division of fx, or the division of fx by gx, okay. So yeah, construct on example, okay. I write it now similar way. If x equal to non-example, I write it here 3 plus I x to the power 5, okay. Difference 1 minus I x to the power 4 plus 6x cubed, okay, plus minus 6 plus 2I x square, okay, plus 2 plus I x plus 1, okay, by gx equal to what? Gx equal to 3 plus I the x square, difference 2ix here plus 4. Then what happened? Then here qx equal to, we write it now, x cube plus ix square, difference 2, and rx equal to 2 minus 3ix plus 9, okay. So this one is some example we also discussed today, okay. In this way, some simple example is obviously here. If we write fx equal to x cube plus x and gx equal to here some x square, then qx equal to what? Qx equal to x and rx equal to what? Okay, rx equal to x. Understood or not? So easy example. So easy example of that. And in this way we also, that means turn so many examples related to division algorithm or polynomials, okay. So today we prove this one by using mathematical induction, okay. Then today I stop here. If you get this type of video, please then subscribe my channel, and if you give like, please click on like option, and if you have any questions, suggestions, comments, write it in comment box, okay. So today I stop here.